Our guest today is Amy Giroux. Once again, thank you for accepting our invitation. Amy is Associate Director of the Center for Humanities and Digital Research at the University of Central Florida and the digital historian for the National Cemetery Administration. She's been using augmented reality and virtual reality along with GIS and other technologies in teaching and research. And in recent research on cemeteries done by Amy has brought new knowledge about Civil War soldiers, Native American prisoners of war, and Seminole War history. Amy, once again, it's a pleasure to have you here. So the floor is yours. And for the ones that want to put some questions to Amy, you can write on the chat the question with the word question in the beginning. So thank you again.
Thank you, Daniel. I really appreciate having the opportunity to talk to everybody today about some of the research that I'm doing. As Daniel said, I work for the University of Central Florida, and their Center for Humanities and Digital Research is involved in a number of different projects across the university and cross collaboration with other universities. And today, the work that I'm going to be talking about is through my work with the National Cemetery Administration. The National Cemetery Administration is part of the United States Department of Veterans Affairs, and it oversees 151 cemeteries in the United States and Puerto Rico. There are more than 4 million Americans buried in these cemeteries. This is some footage that I've filmed during my work today, and today I just want to talk about briefly how I became involved in digitizing cemeteries. So each of these cemeteries is unique, and each headstone, even though from the air they look similar, they all are unique as they identify individual people or persons buried in the cemetery. Now, some of the national cemeteries have a few hundred graves. Larger ones may have hundreds of thousands of graves. And the work I'm doing involves ways of engaging students at all grade levels and the public in general to engage with the people who are buried in these cemeteries. From these graves, these are Union soldier graves from the Civil War. The one that's coming up here is an individual headstone that someone whose comrades spent money on, buying a personal headstone for him. These are United States Armed Forces, and the project is to memorialize these both within the cemetery and externally. So I want to give you some background information on how I wound up creating, or co-creating, I should say, a digital infrastructure for cemeteries, and that starts with a UCF project. From 2017 through 2019, a team of history faculty and staff, myself, and various undergraduate and graduate students participated in a project called the Veterans Legacy Program, and this was sponsored by the National Cemetery Administration. I was the technical lead on the project and created the website, excuse me. And we created various instructional materials for K-12 classrooms. And we also took grade school students on field trips to a couple of different cemeteries here in Florida. And these field trips had educational stations. So the students were split into groups and they would rotate through the various stations at the cemetery. And the professors and the university students would discuss different topics associated either with the cemetery itself, with the conflicts, the wars that were represented in the cemetery, some of the specific veterans that were buried in those cemeteries. And there were also stations that included hands-on activities, and this was my station. I did or allowed the students to do headstone rubbings. And they thought this was really cool because when they came up to the headstones, we had already wrapped the interface material around them. So it was kind of a mystery as to who the student would get until they started doing the rubbings, and the names and information would come out on the rubbings. And they were also happy because they got to take them home. This is an example of some other materials that the students at UCF created. These university students made a series of 6 videos. These are educational videos on World War I. The students created the storylines for them. They found archival footage and photographs. They interviewed various people about them. They actually voiced the narration for each of the videos, and they did all of the video editing. So they learned the technology to go along with this, and also, you know, have this type of creation, artistic creation, so to speak, that they've created for the project. Also, the history students would write biographies. Now, these were courses in undergraduate history, some graduate history courses, and the students would write biographies, research and write the biographies of veterans buried in Florida national cemeteries. And these biographies wound up being incorporated in a lot of the K-12 materials. This particular biography was written by a graduate student at UCF. And David Moniak was one of the first Native American graduates of the U.S. Military Academy, and he was killed at the Battle of Wahoo Swamp during the Second Seminole War, which I'll talk about that in just a minute. But these biographies are all online. The students wrote over 200 biographies over the 3 years of the project. These are for veterans who are memorialized or buried in 3 U.S. cemeteries in Florida, but also 2 American Battlefield Memorial Commission cemeteries in France, the Meuse-Argonne and Asmarne. And we actually took a group of graduate students in the summer of 2018 to France. And they collected headstone photos, they collected the latitude and longitude coordinates of each of the headstones where we had biographies associated with them. And they did some research on site at various places where these Florida soldiers had fought battles and died during those battles in World War I. And one of our students, he was an undergraduate student, his research and biography was on Clyde Emerson, and the student actually had replica made for Clyde. They took those France, Clyde's head for the duration we were working in France, which was kind of neat. So this example is from Florida National Cemetery, and each gravesite for a veteran who has a biography associated with them has a pin on the map. This particular cemetery has over 150,000 burials, and we have about 180 biographies for this particular cemetery in 5 different sections. So the pins are color-coded by branch of service. Black being Army, the dark blue being Navy, red being Marines, and so forth. So these are all geolocated on the map on our website. So when you click on a pin, it's going to bring up a photograph of the headstone and some brief information about the veteran who is there or memorialized there. And then clicking on the headstone photo will take you to the biography of that person. And I showed you an example of that earlier. So the students researched and wrote the biographies. They used a Garmin GPS unit to go around and collect the geolocation information for each of the grave sites. They took the headstone photographs also. And then I actually taught some of the students to do the HTML and CSS coding to create the HTML versions of the biographies. And then I connected all the biographies and data into the actual website. And from the technical work that I did on this project, I received a personal contract with the National Cemetery Administration, and they hired me. I worked for them 1 week out of a month. And my title is Digital Historian. And for the rest of the presentation today, I'm going to talk about my work and my collaboration with various faculty at UCF and with undergraduate computer science students who have helped me with the data processing. So when I started my work with NCA, I've traveled across the United States collecting data in various national cemeteries, but my first playground, I guess you could call it, for my methods was at St. Augustine National Cemetery, which is about 2 hours from my home. The cemetery is about 1.4 acres in size and contains about 1,300 grave sites. The earliest headstone with a date on it is 1828, and these pyramids in the cemetery, there's actually 3 of them. These cover mass graves of burials from the Second Seminole War, and that was fought between 1835 and 1842. And at the conclusion of the war, the government collected some of the dead and interred them in these pyramids. And I'm working on a side project to identify the men in those pyramids. And the possibility exists that David Moniak, who I mentioned earlier, is also within those pyramids. So my tasks at this cemetery were to test different ways to digitize the physical space of the cemetery and experiment with ways of bringing that information to a public audience. And my collaborations there began with some colleagues from UCF who helped me with a variety of data collection methods. And the idea here was to try to figure out what was the most efficient and effective methods of being able to collect the spatial data. So Dr. Stephen Medeiros was from the Civil Engineering Department, and he helped me do a GPS survey of the cemetery. Dr. Lori Walters, she has a joint appointment with the UCF History Department and the Institute of Simulation and Training. And she did a LIDAR scan, actually many scans. She did a survey of one section of the cemetery. And then I used a drone to capture data both for creating maps and modeling within the cemetery. So the GPS data collection, 4 of us, 2 graduate students, Professor Medeiros and myself, who it took us 2 6-hour days on site. Plus the 4-hour-a-day travel time to go back and forth between Orlando and St. Augustine. And Dr. Medeiros, they usually work in the Mosquito Lagoon, which is a body of water on the coast of Florida. So the students and the professor were quite happy to help me with this project because they didn't have to wear hip waders and be immersed in water for hours on end. So we did the coordinates of all 4 corners on every marker in the cemetery. Plus we did some marks of things like sidewalks and the driveway and, you know, other physical items within the actual cemetery. And we created a GPS point cloud. This is the point cloud, and you can see these are the pyramids, the corners of the pyramids down at the bottom. And then I took the point cloud and I created a Plainmetric map within ArcGIS, and I wound up drawing the polygons for these by hand, connecting, essentially playing connect the dots with the GPS point cloud, and I created polygons for each of the markers within the cemetery, along with the sidewalks and so forth. For the LIDAR, Dr. Walters, she usually scans huge things like multi-story buildings or jumbo jets. She did the TWA building at an airport in New Jersey. So she usually does very, very large objects with the LIDAR scans. So she was interested in helping me do this, but we weren't sure whether, you know, 2 scans in a section would be sufficient or, you know, if it would take 10. So we experimented in one of the smaller sections of the cemetery. And my hope was that with the laser scan that we'd actually not only, you know, map them spatially, but that we would be able to capture some of the imagery off of the faces of the headstones. That unfortunately didn't work as well as I hoped because the laser refracted off the marble and it left holes in a lot of them, and the quality of the scans across the faces of the headstones was not as good as hoped. This is one of the single scan point clouds from the LIDAR. The actual LIDAR scanner was set in this area when this was taken. So you can see how all of the headstones in the area occlude, you don't see these data points because the headstones themselves cast the shadow, so to speak, or the holes. So we wound up doing 15 scans in this section. The scans are the bubbles. This is where each of the scanner heads was during it. And what I found quite interesting in this is the combination scan or point cloud of all of the scans, was the length, the distance that scanner could actually see. It picked up points all the way down the other end of the cemetery. This is one of the point clouds, and you can see that the headstones really aren't clear. In the camera version, it actually does a photo pass to get some of the colorization, and those you can actually read the headstones, but this photo pass data is not really available for me to model from. I just get the point cloud data. So from the point cloud, I created LIDAR imagery of this section. I also created a 3D model, and I have also taken about the back 4 rows of this model and pulled it into virtual reality, which is kind of neat. You can put your VR goggles on and actually walk through that section of the cemetery. And I hope at some point in the future to be able to do this on not just a single section of it. The LIDAR scanner that we used was not, it didn't geolocate the points in space. It was an older model. Dr. Walters now has a newer model of laser scanner that actually gives you the X, Y, and Z coordinates of every point in the scan. So my hope is that when we're able to travel again, that we'll be able to go back to the cemetery and redo this so that we get the geospatial coordinates of these 3D scans. And then for the aerial collection, this is my typical outdoor office, my car, the drone, my computers, all of the pieces that I need to run effectively out there. And I have a DJI Phantom 4 Pro drone, and this wound up being the standard data collection method for the other cemeteries that I've worked in across the US. It's not easy or cheap to be able to use, or ship GPS transponders or LIDAR scanners across the country. The drone itself was a whole lot easier to move, though I have on a number of occasions wound up with it sitting between my feet on the airplane because it was too big to fit in the overhead bins of some of the smaller jets. But the logistics of using a drone in a cemetery has been a little bit more challenging because it's an aerial device. I have to fly it. A lot of the cemeteries are actually within the approaches to regional airports or local airports. So I've had a lot of conversations with the control towers at airports, getting permission, letting them know when I'm flying and so forth. And the most difficult one that I worked on was Alexandria National Cemetery in Washington, D.C. It's the U.S. Capital region, and it's a no-fly zone. But it took us about 6 months to get all the proper paperwork together and the appropriate people actually on site with me, and I was actually able to fly there also. The other challenge with a drone are trees. Flying over them blocks the view of some of the headstones in the cemetery. Flying under them does not give enough uniqueness to the images that the drone takes. Green grass and a white headstone looks just like the next set of green grass and white headstone. So I experimented with ground control points also to try to get it to where the stitching software could actually put the pieces together for the mapping. And over the course of time and experimentation with us, I gave up on the flying under the tree level, and I just fly an overhead aerial set for the data. And then I wind up creating the polygons and so forth for the tree, the ones that are blocked by the trees. So I do 3D drone mapping using photogrammetry. The obelisk on the top is in South Dakota. The pyramids and this obelisk are in St. Augustine. They're situated right here. And I create GeoTIFF imagery from the drones. And for those of you who don't know, GeoTIFF is essentially an image that has geographic reference information embedded in it. So it has the coordinate system, the map projection, and all of the other data that's needed to actually place this in the world space. So I can place this on a map and it knows, you know, where it is in relation to the world. The other data collection that I did are Headstone Photographs. I experimented again with different techniques. Shading the headstones, shading under trees is always a problem. Just for ease of speed, you know, taking a flash unit around like that was too time consuming. So we wound up trying to do most of the eastern facing headstones in the morning light, so the sun was casting the light on them enough, the western facing stones towards the evening. And eventually we got a set of photographs that were, you know, legible for what we needed them to be. And the other thing that I do on site are 360 immersive videos. I have a 360 camera that I film between around 2 minutes in sections within the cemetery, and then I geolocate those videos on a map of the cemetery. And this project with the 360 videos has been interesting in that I've learned to erase tripods and shadows and things from the 360 videos, so that when the user, if you look at these with your phone, you can actually gaze around with your phone and look around the world. And when they look down, now they see grass instead of the tripod that actually took the video. So it's been fun doing that too. So this is a prototype of a map that I'm currently working on. And these interactive maps are going to be public facing at some point. Excuse me. And I've used a JavaScript library called Leaflet. And then I overlay my drone imagery to get a much better resolution and zoom capabilities than what you can do, say, on Google Maps. And I've created layers that allow the users to look at things by branch of service, the conflict, what awards, the marker styles, so they can look at which markers are current day style markers versus the, say, the Civil War style markers and older ones like that. So they can choose the layer. It color codes the polygons on each of the headstones. These pins are for other imagery that I've taken. The 360 videos would be pins like this on the map. And you can turn the imagery on and off and so forth like that. So the data collection that I did through the GPS survey, through the drones and the LIDAR and all of these things, how I turned that into this map was very slowly, very time consuming. You know, I had the GPS point clouds, I had to draw polygons. I had the video imagery, I had to, you know, turn that into videos. I had to take the latitude and longitude information from each of the polygons, merge it with the burial information so that I could do these query layers and, you know, make it where you can pop up information about each of the burials in there. All of this was done manually, and what I learned from the process is that it was very inefficient, and I really needed to come up with a better way of doing that. And how I did that, one second, was by building infrastructure to help me process the data faster. And what I worked with was teams of students at the University of Central Florida. So the undergraduate degree in computer science requires a 2 semesters senior design course, and the students must pass the class to graduate with their degree. So sponsors of projects, both within the university and outside in industry, propose projects at the beginning of the first semester, and then the students pick what their top 5 choices would be for a project that they would like to work on. And then the computer science professors assign teams of students to work on the various projects. And I've been extremely fortunate to work with 70 different young men and women on 16 different teams over the last 5 years on projects that were associated with the center where I work. The students gain valuable project management, design, implementation, and communication skills while doing these experiential learning projects. They also get a very strong line on their resumes. When you can say that you've worked on a project for the National Cemetery Administration or, UCF Department of Engineering or NASA, some of the other big name companies that do these projects or sponsor projects, that looks good on a student's resume and it helps them get jobs, which is very important. So I've had 4 teams with a total of 18 students who have helped me with the cemetery work by building infrastructure components to help me process the cemetery data. The 2 teams pictured here completed their projects before the pandemic, and they were able to actually present them at the Senior Design Showcase. And one of the teams, which is not pictured here, they presented their project over Zoom at the end of the spring semester. And I have another team who will be doing their final presentation next week over Zoom. So when I meet with the entire 100+ student class at the beginning of a semester, I'm allotted a 10-minute time slot. I spend about 6 minutes of that doing a PowerPoint project pitch, outlining the requirements of the project, what I want the software to do. If I have any hardware requirements for it, I talk about that, what platform I want it to run on. And then I have 4 minutes of question and answer with the students so that they can clarify, usually the students who ask me questions in it are ones that wind up actually assigned to the team. You can tell the interaction with the students, whether they're quite interested with it or not. And then after the students are assigned to a team, in the first semester, they spend the time investigating the problem itself. They define roles within the project. So if there's a database component or a user interface component and computer vision, things like that, they divide the project roles up between themselves as to what interests them or what it is they haven't learned yet in a class but want to learn, those kinds of things. Then they start prototyping the project, and they create a 100+ page design document that describes all of the software that they're going to use, the platforms, and so forth. Then in the second semester, they create a 6-page conference style paper. They go through a critical design review. They complete the software project, and then they do 2 or 3 presentations. Typically, they will present at the Senior Design Showcase and then at a K-12 STEM day where grade school students come into UCF and can look at all the projects. And this is, of course, pre-COVID. Right now, I believe this semester they're going to be creating a 8 to 10 minute video as their presentation. I'll find that out next week. And then the computer science professors are the third presentation. They do their final presentation in front of the class professors, and then they have to find 3 other computer science professors to watch their presentation and grade their presentation. And the student teams usually like me because I'm graduate faculty and I actually count as one of the professors, so they only have to go find 2 other ones to do their presentations. And then they turn in a 150 page. They essentially add, excuse me, about 50 pages to their original document to show the final project and instructions and so forth. So the 4 projects that have been created for me or in the process of being created, this first one, excuse me, was a team of 4 students. And this is a sample of the first page of their conference paper. The center image is the camera rig that they created and used for the project. And then the right-hand images are a couple of samples from their actual app. And what they worked on was an app to measure distances in stereographic images. So the photo in the, find my cursor here, this photo, it's kind of small here, but this is an old stereogram photograph of St. Augustine Cemetery back in about 1865. And the white vertical pieces here in the image are wooden headboards. And over time, those headboards rotted away and they were replaced with marble markers. This is the current day cemetery. And these markers have unknown US soldier is what's listed on them. But I've deciphered 9 names on these headboards. And what the students were tasked with doing is trying to calculate distances in photographs like this so that I can measure in the present day and figure out which of these headstones correspond to which of these headboards. So the group spent an entire day out in the cemetery with their camera rig. One of the phones here is one of the students' iPhones. And the other one, our university library allows students to check out hardware. So they can check out laptops and iPads and iPhones. So they wound up getting a compatible iPhone, same make and model, so that the images that came out of these 2 phones down these cables and into their other hardware connections, they used the images and some software they wrote to actually merge the 2 iPhone camera images into what looks like an old stereograph photo like this. And then they created a computer vision library and analysis tool to actually do the calculations using what's called epipolar geometry. It's over my head, but they were able to work with the chair of the math department to learn about epipolar geometry. And then they created this app that does these distance measurements. So the second project, I spend a lot of time cropping photos and renaming them so that they're easily accessible programmatically from my website and things like that. So the second team, though St. Augustine's got about 1,300 headstones in it, the Alexandria Cemetery in Virginia has over 4,500 headstones. So just the time it takes to crop and rename and do all of this kind of stuff was very, very time consuming and slow. So this second team was a team of 5 students, and they created an app that takes a comma delimited file that I have of the burial information. It has the names, you know, the information about what war they were in and the gravesite information. So it imports that into a database, creates some indexes for it. And then they let me point to a folder of photographs and name a pattern for the output file name. And then it processes these photos. It crops them down to the edges of the actual headstone within the picture. So the computer vision understands what a headstone looks like, crops it down, and then it runs optical character recognition or OCR on it so that it can pull out the name information off of the headstone photograph, takes that information, looks it up in the database, finds it in the database, takes the naming pattern, which are columns in the database fields, and renames the files based on those fields. This is great. It works really well. The ones that it can't process, it puts in a failures folder, and then I go through that folder manually and figure out, you know, who it pertains to. Most of the failures are extremely eroded headstones. The older ones, a lot of times I can stand right in front of the headstone and I can't read it either. I don't expect the computer vision to do much better. So those are the ones that I have to go through manually, or things that have duplicates like unknown soldier. There's lots of them. So the algorithm doesn't know which one to pick out, and I have to go back through and set those correctly. And then the one that's currently being developed that they're presenting on next week, this is, we're calling it cemetARy drone image analysis. This is a 5-member team. And what they're doing is creating an app that takes the GeoTIFF image. This is one of the GeoTIFFs of Alexandria, and it runs it against a computer vision model that they've created and trained that recognizes headstones. And this one, the current model, it actually pulls some of them out when it's even under the tree line. You know, if there's a piece of a headstone showing, it usually can pick those out also, which is kind of cool. And then once the polygons are created, it allows you to go in and annotate some of them. So I can say that, you know, this is row 5 and it'll annotate the data for me and show that all of these are in row 5, row 4, row 3, row 2, and so forth. And then it exports this data in, since it's a GeoTIFF image, they calculate the corners again of the polygons, and then they export all of that data that I was drawing by hand and merging manually into a GeoJSON file, which I then can combine into the burial information and use it on the interactive map on the website. This one is going to save me an extraordinary amount of time. And the students actually said that they're able to process up to 35,000 headstones per image. Not that I have ones that are that large. They actually were taking pieces from Google Earth images to do the training. But in the future, if I do wind up doing some of the larger, extremely large cemeteries, it'll be able to still process that data efficiently for me. And then this project, this is the last one that I want to share today. This one is going to eventually be public facing. It was a team of 4 students, and they created this app to run on Android and iPhones, and it helps cemetery visitors navigate to the gravesites themselves. So we worked with a cemetery. There's a city cemetery here in Orlando that has 3 different military sections within the cemetery. So we collected the data from those 3 sections, and instead of meeting on campus for our meetings, we actually would wind up meeting in the cemetery itself, which was fun. So they created a search screen. You can put in, textual information, last name, things like that. You can look at, everybody in that cemetery that served in World War I or served in World War II, things like that. You can pick out a specific section of the cemetery. And then once you hit search, it'll bring up a list of 1 to however many. Since I put in a name, it only has 1. But if I put in, conflict, it could have screens worth of it. And then once you click or tap on the name that you want to look for, it brings up the basic burial information about the person. It brings up a headstone picture if it exists in the database. If there's a biography that one of the university students has written, it'll link out to that. And then it has this navigate to veteran button down at the bottom. And when you tap on that, it brings up a 2D map of the cemetery, and it gives you a marker at the end to where, a marker at the end to where the gravesite is, shows you where you are, and then gives you a line to follow. It gives you, directional information on how to walk from where you are, or even drive. If you come in the entrance to the cemetery, it'll show you, that your stop is over here, and then you can figure out which roads to drive on. But if you want to use the augmented reality version, there's this button up at the top that says switch to AR. And what this does is it actually puts this virtual ball above the grave that you're looking for, and it gives you a directional line and the distance on, the ground. This is looking out your cameras or your cell phone's camera, showing you what's there in that specific time and place. And it shows you where it is that you need to walk to get to that gravesite. Now, GPS on most phones is not precise enough to really get you to the perfectly exact spot. It's going to be some number of meters off in any direction. So the app draws this sphere in space at the center of its search circle, I guess you could call it. And then it draws this ring. You can see the dotted line here. It draws a ring around the area where your headstone that you're looking for is going to be. So you're within 10 feet or so of it. So it gets you, close enough that you can actually walk and then look at the few headstones around you to find the one that you were specifically looking for. The other option that they have in the app is if you're just wandering the cemetery and you find a headstone that you're interested in seeing more data about, they have an optical character recognition part of the app called Scan a Grave. And again, using the camera on your phone, you hold it up to the headstone itself, and you can either take your finger and drag the little pencil like this to outline the text to select, or there's an auto feature that picks out the pieces, and then you can tap on each of the squares. And what this does is it allows you to fill in the search screen. You know, I tap on Andrew and it puts it in given name. I tap on Jackson and it puts it in the surname, and then you pick search. So it's another way to do data entry versus sitting there and typing with your thumbs. So I'm going to be pitching this navigation app again in the coming spring to a new set of teams, because the intent for this second phase is going to be to have downloadable cemetery packs. A lot of the cemeteries, especially ones like Florida National, it's in the middle of the Withlacoochee Forest, so the cell phone reception out there is minimal and sometimes non-existent. So with downloadable cemetery packs, you'll still be able to use the GPS location information and the app on your phone to do the navigation, even if you can't get a cell signal. And this will be very helpful, like I said, for cemeteries where you really don't have good cell phone reception. Here's my contact information. I'll go ahead and leave that up for now. And I thank you again for coming today, and I'll answer any questions that you have.
Thank you, Amy. It was an amazing presentation of amazing collaborative work with students. I made some approaches with written sources, not with that type of source that you use, but it is amazing what you achieve with those applications in the end. So we have some questions and some comments here. Several questions regarding the privacy issues that surround this type of work. Although you work with graves mainly from the 19th century, there are some questions about it. One is from Ben, and he asks if the drone in the US, the operator of the drone has to have a license to operate in the graveyards. And related to that, there were also two other questions regarding the permission that is needed not only to fly the drones, but to process and digitize the information that is there in the cemeteries, because there is potential ethical concerns associated with mass graves, with relatives and so on. And Catherine and Sally also want to know something about that. So okay. if you can share us something.
Okay, I'll start with the licensing. Yes, I had to get an FAA, Federal Aviation Authority license to fly the drone. That was a test. Took about 2.5 hours, I think, to take the test. Studied for about 6 months to make sure, because I had to learn how to read charts and, you know, that kind of thing to fly safely in the spaces, especially around airports. Flying the drones in the national cemeteries themselves, since I am a federal employee while I work on those sites, I have permission to fly the drone there because it's part of my work. I have actually had people come up to me when I was working in St. Augustine and flying the drone. They came up angry, saying that, you know, why are you flying this drone in the cemetery, and, you know, that kind of thing. And by the time I explained to them why I was doing this, one of them actually was crying. You know, being able to make these spaces available online, you know, for veterans to be able to visit these cemeteries digitally if they can't, you know, visit them in person is, you know, important, and memorializing those who are buried here is important. As for privacy, the cemeteries themselves are a public space. The images on the headstones and the the names on the headstones and things like that are available in the public. The people who we're writing biographies for, we're not really working on ones that are closer to the current day. We're working on Seminole War, 1830s, 1840s, Civil War, the older ones whose families are may not even know they're there. That's one of the pieces that I'm working on with the Civil War veterans in St. Augustine. A lot of these men's graves are marked with unknown U.S. soldier headstones, and I'm actually trying to restore their names to their headstones. So that's important also. But for processing the data and using the drones in public cemeteries, that's going to be the call of the sexton and the associations that run those cemeteries. I had permission to do the flights in Greenwood Cemetery, which is our city cemetery, to be able to do the military sections of that cemetery. Again, explaining to them with the Veterans Legacy Program that we're trying to do this memorialization of veterans. There's also a second piece to the Veterans Legacy Program called the Veterans Legacy Memorial. It's an online platform similar to, I think I can think to call, it's like Find a Grave, but for the burials for veterans in national cemeteries. So they've created a platform that has information for all of the 4 million plus men and women who are buried in national cemeteries. Families can go in and they have login permissions where they can put photographs and biographical information about their loved ones up on that website. And the data and the maps that I'm creating here will tie into that platform. So when you look at a gravestone, say in St. Augustine, if a student biography wasn't written about it, there may be information on the Veterans Legacy Memorial platform and it will point out to that. Yeah. So, it's that kind of connectivity of the data.
Okay, Sally made also a comment because she was involved, and we were mentioning this type of project in a call that we participated in a few years ago, and she mentions as a commentary that because there are some landscape apps in the Flanders Fields Museum in Belgium. The link is on the comments. On the chat, and probably those apps have some features that are similar to the ones that you are implementing in your work. One other question. Well, I made a question earlier in the presentation, but it was responded in the end with a work from one of your students, because I was wondering when you presented the pictures of the photos of the graves, if it was possible to automatically extract the information and incorporate that information in the infrastructure, and it was one of the apps that was built by the students. So that, in that process, you were in the end of the presentation, you answered my question, I think. Another question. Yes, Sally wonders if the transcribers software can be used for the OCR on the gravestones. I don't know if you...
Transcribus? Yeah, I'm familiar with that. The students are using, I want to say Tesseract, I believe is the application that they're using to do the OCR. Transcribus, I was under the impression it was more for handwritten fonts versus, print fonts, but that's something I will look into. Thank you.
Okay. Another one is that if there are archival lists of soldiers that could be used to train that type of OCR.
I have the, that was part of the project. I have the data for the headstones that are in there, but we didn't have the images before I went out and took the photos. Okay. You know, so the OCR that the students do, and then they take that and compare it to the data that I already have. And that matching process, if the headstone is legible, works very well. Again, if it's eroded, then we start to have issues. But the clean, legible headstones work quite well with the OCR and the lookup in the database. Okay.
And also from Sally, she wonders if you know that if there are similar projects around the world that apply similar methodology to this type of information. Do you know of any other project similar?
Not that I know of. I mean, there are a lot of things like Billion Graves where they have an app that people can walk a cemetery and submit information to their platform. But I'm not aware off the top of my head of any that do, you know, this level of processing with the, you know, from the polygon level through the OCR to the database.
Okay. One other question, Ben, regarding but I think you already answered that, because he was wondering if many people were trying to take pictures in the cemetery, if that would make others that were visiting the cemetery uneasy with the situation. And I think you probably mentioned that when you were using the drone.
Yeah, the interesting thing that I found, at least in St. Augustine is a tourist town. It's the oldest continually inhabited city in the United States. It was founded back in the 1500s. The cemetery itself has a low rock wall around it. And a lot of the visitors, they just come and they look over the wall. They never actually come into the cemetery to walk among the graves. And I was quite curious about that. And the lodge, cemetery lodge building is actually the Inspector General's office. And one of the soldiers in the office there had come out and talked to me one day. And she said that there are people that actually come and knock on the door of the lodge and ask them if it's permissible for them to walk in the cemetery. So it's funny to me that visitors, you know, I don't know if they just don't feel comfortable walking in cemeteries in general, or they think that just because there's this low wall that allows you to look over it, that you're not allowed to, you know, come in and walk through the graves. So most of the time that I've been there, there are people that come around the outside, and if I'm doing something interesting, like recording, I do audio recordings of the ambient sounds in the cemetery, so that when I create the virtual reality, you can listen as well as see. They'll come over and they'll ask what I'm doing, because, you know, you have various microphones out in the cemetery, or the drone, things like that, that pique the people's curiosity, and they'll come talk to you. But most of the time, there are people that'll just, if they're there to visit somebody's, you know, a specific grave, I stop what I'm doing and I go elsewhere and I wait until that moment is passed. You know, I don't intrude on any of that kind of thing that's going on in the cemetery. But there's people, one of the questions and what started one of these pieces of the project was a gentleman came in and he said, I visit all of the Vietnam veterans' graves in every cemetery that I come to. Do you know where all the Vietnam veterans' graves are in this cemetery? I knew where two were because I had walked by and I had noticed them, but this was before I had mapped it all. And I said, I really can't tell you specifically where they all are, Once I created the first map of St. Augustine, there's 27 Vietnam veteran graves. And now I can show him on an app if he ever comes back at the same time I'm there. And I can say, here are the 27. And then what he's trying to do in that cemetery, he can do, because with the app, he'll be able to find all 27 of those Vietnam veteran graves. And I mean, that kind of interaction, that's why I'm trying to get this data out there so that people can find who they're looking for.
Yeah, it's a great job, and again, it's also great that you involve all so many students in the job, and so many students that are in the end they get some knowledge, some expertise that it's quite important for them to when they get out in the real world,
Yes.
looking for jobs and something like that. Well, one final comment, Sally. Also, if you look at in the chat, she suggests a new OCR package, recent. I didn't know this one also, and probably it will be interesting if you look at it. So once again, Amy, many thanks for your presentation and for accepting our invitation for the Digital Humanities Hangouts. We will have another one very soon, in 2 weeks now, in December. Stay tuned in the Twitter and in the email, because we are going to circulate the information. Amy, once again, thank you for your wonderful presentation.
Thank you for inviting me. I really appreciate it.
See you all. Thank you.
Thank you.